with our fundamental expression, which is that we could relate strain to 1 over the gauge factor times the change of resistance over R. But remember, we don't have enough sensitivity in our ohm meter in order to kind of measure experimental strains that are going to be on the order of microstrains or even smaller. So we need to kind of measure this indirectly through this kind of change in the output voltage as a function of strain. We need to kind of build some type of circuit that's going to allow us to measure this resultant change in resistance and then thus our strain. So one of the first things we can kind of think about this and get started in order to kind of build up to our Wheatstone bridge is by first thinking about a voltage divider circuit. So we can see the circuit kind of right here below, and we can imagine if the first scenario, let's say our output voltage is, there's no current being taken out from the output voltage, i.e. the output voltage is 0. Well, then I could use my kind of this standard, hopefully everyone knows this equation, and then I could figure out, well, what's the current in the system if there's no output voltage being drawn? So I know that these resistors are in series, so I'm just going to add them for that equivalent resistance, plug it in for R, and I can find an expression for my current. Now, if my output voltage is not 0, I can then still use and actually write an expression for what is the output voltage. It is just going to be the current flowing through here times the resistor, because again, I'm just looking at the voltage here and here. So I know R2, or I could kind of, hopefully I'm giving that value here, but I also know what I is from our previous description. This is the current, the current that's flowing through our voltage divider circuit. So it's just going to be a function here, you're plugging and chugging, and you just get this expression right here. And you could rearrange this I equals VI, over R1, and then we get this expression for your output voltage. So that's your first circuit. So not too bad, right? So this is your output voltage. Again, if there's a non-negligible current flowing, you could kind of rewrite this as I. But anyway, I'm going to try to be consistent with that kind of notation. And VI is, again, this excitation voltage. VI is going to be typically given to you in a problem. So first circuit done, no problem. Now, we could use this idea of this voltage divider circuit to build up and actually create our Wheatstone bridge circuit. And you're going to see something very, very similar from our voltage dividers and when we compare it to our Wheatstone bridge circuit. Specifically, you're going to see the Wheatstone bridge is essentially 2 voltage dividing circuits. So we'll talk about that and see that in the next video. So Wheatstone bridges, we're almost there, or actually not almost there, but we're almost through our circuits, and then we can get back into our mechanics. So I'll see you in the next video. Thanks. Bye.